Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 3, Section 3, Stretching and Compressing Graphs of Functions Notes, Part 1. So, right off the bat, let's start with some stretching here. So, graph the following all on the same grid. So grab your graphing calculator. I want you to be able to graph these. So the first thing, y equals 2 square root of x, y equals 4 square root of x. Now, really you should be starting off with y equals square root of x. Now, we've done enough of these. X is 1, y is 1. When x is 4, the square root of 4 is 2. When x is 9, 5, 6, 7, 8, 9, the square root of 9 is 3. The original function goes something like that. Now, what does 2 times the square root of x look like? Well, you're literally multiplying it by 2, so it becomes twice as high. So 4, 6, so. Four times as high. Y was originally 1. 4 times 1 is 4. Y was 2. 2 times 4 is 8. 5, 6, 7, 8. Y was originally 3. 3, 6, 9, somewhere up here. So it goes off the graph. Right? Well, that's what we call a stretch. Now, a compression, on the other hand, y equals 1 half x. What happens to that? Well, y was 1. Half of 1 is a half. Y was 2. Half of 2 is 1. Half of 3 is 1 1/2. So it goes something like that. So that's y equals 1 half square root of x. Now, take a wild guess what 1/4 square root of x would be. Yes, 1/4 is high. Something like that. Now, pause the recording, double check my work, graph it on a graphing calculator, please. So, when you do that, come on back. Welcome back. Now here, summarize this the vertical case. Given the curve y equals f of x, and the point xy on the curve, if a, that's the number in front, if a is greater than 1, then y equals a times f of x is a vertical stretch of the original curve by a factor of a. Now, if a is a fraction less than 1, a is greater than 0 and less than 1, then a times f of x is a vertical compression of the original curve by a factor of a. Now here you have to be careful. We're supposed to call this a compression because it's not a stretch, but the diploma calls it a stretch, even though it is a compression. It's a stretch by less than 1, makes it smaller. Now, what I really want to stress here is the point xy becomes x and a times y. All right? So, and the wording, careful. The graph of the function y equals f of x is vertically stretched about the y-axis by a factor of 3. The new equation is y equals 3f of x. The graph of the function y equals f of x is vertically stretched around the x-axis by a factor of 1/4. The new equation is 1/4 f of x. Yes, I will sometimes call this a compression because it's smaller, but it's technically, the diploma people call it a stretch, so I should call it a stretch too. All right? Good. Now, moving on. This is the graph of y equals f of x. Given the transformation y equals 2f of x, what transformation is used here? Well, here a equals 2. So it's a vertical stretch. Or abbreviation, vertical stretch times 2. So, what is the image of the point 2, comma, minus 3? Now, 2 comma minus 3 is right there-ish. So, this becomes in mapping notation, xy becomes x comma ay, or in this instance, 2 comma minus 3 becomes 2 comma 2 times minus 3, or 2 comma minus 6. So that point will be down here. Now, this vertical stretching is around the x-axis. Okay? So, that leads to the next point, the invariant points. Wherever y is 0, that's where I have my invariant points. Y equals 0. That is y equals 0, or the x-axis. So roughly minus 2 comma 0, 1 comma 0, and 4 comma 0. Right? Now the next bit is draw the transformed graph. So basically, every point, every y value gets doubled or twice as high. So here the y is 3, that becomes 6. Here the y is 2, double that becomes 4. That's roughly 3, so that becomes roughly 6. Let me see. That's 3, that becomes 6. Now down here, that's roughly 2.5, so double that, that becomes 5. So now we place the connected dots through the invariant point. So I go down, swing back up through this invariant point. Here, come down, this invariant point, and scroll up again. So what I've got is something like that, about twice as high, or twice as deep. All right? Now, state the domain of each graph. Well, the domain of the original graph, since the arrows keep on going, I'm assuming x is all real. Now, for both of them. Now, the range gets a little picky. The original, looking at that graph, looks to be roughly minus 3. Y is greater than or equal to minus 3, or minus 3 comma infinity. Now the new one, notice it was twice as much, because the vertical stretch times 2 that's messy. I can write better than that. 2 times minus 3, or minus 6 comma infinity if you want to use the fancy brackets. All right? So that's vertical stretching. Now I'm going to stop here. I want you to review this part of the video if you have any questions. Any questions, shoot me an email. Otherwise, let's go on to the next part. Okay?